Hi folks, we're going to take a look at number 15 on page 333. So the information they give us are about these two vectors a and b. They give us the magnitude of a and b, which are 3 and 5 respectively, and they give us the magnitude of the sum of these vectors, and they want us to find the magnitude of the difference. Okay, so we see here that this is going to be a geometric problem. The vectors are not given at all in algebraic form. And the other thing I notice is this inclusion of both the sum and the difference of these two vectors. So I'm hoping that when you think of these two at the same time, you think of our parallelogram representation of the sum and difference of two vectors. Okay, so let's say we've got vector A, okay, and then here we've got vector B. It's a little longer. Okay, we know that the sum is represented, so notice here they're tail to tail. The sum is going to be represented by the diagonal of the parallelogram formed by these two vectors. Okay, that starts at the two tails. Okay, so this vector here from the two tails to the other corner. So the blue vector is going to be representing A plus B. Okay, and then if we want to consider the difference, we know that's given by one of the vectors that joins the two tips. Okay, so if we want to be precise here, it's saying A minus B, so we know that's going to be from the tip of the second to the tip of the first, so this is going to be that vector there. So the red vector is A minus B. Okay, so how to solve this problem? Well, since we've got the magnitude of the sum, I'm going to be working with this triangle here because I know this is A, I know its magnitude, B, I know its magnitude, I know the magnitude of the resultant of the sum, so I may be able to find an angle inside this parallelogram. So I'm going to be finding this angle here, but because this is a parallelogram, this angle, which is inside the triangle which contains the difference, is just going to be supplementary to that one. Okay, so let's go ahead and solve this problem. Okay, so I'll actually just redraw the diagram just so that it's very clear. So I'll start with the sum of the two vectors and I'll draw them tip to tail. So there's A plus B, and this is the sum A plus B. So here A, that's B, and this is A plus B. Okay, now I know the magnitudes of all three vectors, so I know that this side is equal to 3, that side is equal to 5, and this side is equal to 7. Okay, and I'm looking for this angle here, which I'll call theta. Okay, so theta is just going to be equal to cos inverse of, well, its opposite side is 7, so it's going to be 7 squared minus 3 squared minus 5 squared over negative 2 times 3 times 5. Okay, and so let's calculate that here. Okay, so we've got cos inverse of 7 squared minus 3 squared minus 5 squared, okay, divided by negative 2 times 3 times 5. And what do we have? We have 100, it's a nice vector, a nice angle, 120 degrees. Okay, so that means this angle here, okay, if we go back to our parallelogram representation, is 120 degrees, which means that, and now I'll switch over to red to work with the other triangle, meaning that this angle is 60. Okay, and so now I have enough information to work with this triangle here, which again I'll redraw. So I again have A and I have B. Okay, but now I'm placing them tip to tail because, tail to tail because I want to work with the difference A minus B. Okay, so this is A, there's B, that's A minus B. I know these magnitudes, this is still 3 and 5, and this angle now I know is 60 degrees, and so now I can find the magnitude of A minus B. Okay, so that's just the square root of 3 squared plus 5 squared minus 2 times 3 times 5 times cos 60. Okay, and let's calculate that, and that'll give us our answer. Okay, so here we've got the square root of 3 squared plus 5 squared minus 2 times 3 times 5 times cos 60. And we end up with about 4.4. Okay, and there we go. So, just to recap this problem here, okay, it was about understanding the relationships between these two vectors, their sum and their difference, with respect to this parallelogram representation. Okay, so I used the fact that I knew the magnitude of the sum. I worked with this triangle here to find that interior angle, which is supplementary to that interior angle, which is inside the triangle which contains the difference of the two vectors. Okay, so two-step problem, but again, it all relied on understanding this relationship between sum, difference, and the parallelogram. Okay, that's it for this one.